Hi, everyone, and welcome to another engaging session in the EAS Talk webinar series hosted by the European Aquaculture Society. My name is Anna Viskovic, and I'm delighted to be your host and moderator today. Today's topic, the power of nanobubbles in a recirculating aquaculture system, will delve into innovative solutions for enhancing RAS. Together with Moleaer expert Jan Erik, we will explore how nanobubble technology is revolutionizing aquaculture by improving water quality, boosting biofilter performance, and supporting fish welfare. This cutting edge approach offers not only environmental benefits, but also economic advantages, ensuring more sustainable aquaculture practices. Nanobubbles are a game changer in aquaculture, offering a sustainable solution to critical challenges such as oxygen delivery, water treatment, and fish health. With nanobubbles, operators can elevate the efficiency and profitability of RAS systems, driving long-term success in our industry. Now, it's my pleasure to introduce our esteemed presenter, Jan Erik. Jan Erik brings over 23 years of experience in sales management and business development within the Scandinavian market. He specialized in helping European business discover and implement Moleaer's innovative nanobubble solutions. Today, Jan will guide us through the science and applications of nanobubbles in aquaculture, shedding light on how this technology is paving the way for a more sustainable and efficient industry. The webinar will consist of 30 minutes presentation followed by 15 minutes live Q&A. During the Q&A, you're welcome to share your questions in the chat or turn on your microphone and video. Please note that this session is being recorded and will be available on the EAS YouTube channel for 1 month. After that, it will be only accessible to EAS members under the EAS Talk webinar section on our website. If you're not yet a member, visit our website to learn more about joining EAS and unlocking exclusive benefits. Without further ado, I'm excited to hand it over to Jan. Jan, the floor is yours.
Thank you for that. Yeah, so like she said, my name is Jan Eric Haagensen. I've had the privilege of leading Moleaer's Norwegian subsidiary since 2022. And Moleaer was established in 2016 after Bruce Scholten, our current CTO, discovered a method to make nanobubbles and patented it. And with Warren Russell, our chief commercial officer, established the company. And today we are approximately 100 employees globally. So today we have over 10 patents and patents pending on methods to generate nanobubbles. And we've tested a wealth of methods and patented the ones that we found the most effective. So today I'm going to be talking about the sector that we deliver our nanobubble technology to in aquaculture, specifically in regards to its effectiveness in RAS applications, recirculating aquaculture systems. So there we go. So with that and our different methods of making nanobubbles, our mission is to unlock the power of nanobubble technology to increase efficiency, productivity, and sustainability. So, and this has made us the leader in nanobubble technology, where we're using this new class of science to pioneer solutions that transform our customers' operations. With our generators, we inject gases into liquids to produce trillions of stable, charged nanobubbles. And we then develop tailored solutions to apply this technology and solve our customers' challenges. And with that, with the concentration of nanobubbles that we're able to produce with our technology, we utilize the properties of nanobubbles to drive faster chemical, physical, and biological reactions, which we're going to dive more into this. So nanobubbles are extremely small. We're talking 2,500 times smaller than a grain of salt, roughly 400 times larger than a water molecule. And they behave like charged colloidal particles. And unlike microbubbles or large bubbles that rise to the surface and burst, they stay suspended in liquids for much longer time. And this stability is allowing nanobubbles to improve gas exchanges and deliver oxygen more efficiently. And my favorite, speeding up powerful chemical biological processes, meaning that you can utilize less chemicals and get more results. So with this, we have over 3,500 installations in over 55 countries, and we're treating a lot of water, over 750 million gallons of water per day. And our company provides solutions. It's not just the equipment. It is very important to Moleaer to understand your process and your need, what is the objective. And based on our understanding of your process, we will be able to recommend where to install and how to use the equipment in order to achieve those objectives. We have a large staff of 8 PhDs that is continually looking at existing methods, applications, and uses of nanobubbles. And we have a very large library of third-party validations. We provide responsive and fast service and to ensure operational efficiency, and this is a very important part of our offering when we come with a solution for any customer. And with this, an international team of water treatment and application experts, where we have offices here in Norway, where I am, in Chile, in Spain, and in the United States. And we use industrial grade components for our high performing and reliable technology. In the US, we produce it in imperial size, and out of Spain, we produce metric for the European market and whatever market needs metric. So I can list up over 10 different sectors where we provide value propositions when it comes to the use of nanobubbles. And over the years, this has made us a category creator. It is, for example, some of these are wastewater treatment, irrigation, surface water, reestablishing the natural lake processes in lakes and ponds, and of course, aquaculture and seabed remediation. And with our technology, we're able to enable these sectors to produce more and use less water, less chemicals, less energy, and also where over 90% of water is used. So with our technology, we're introducing 2 forms of gas into water, directly dissolved and nanobubbles, a very efficient and high amount of nanobubbles. And the dissolved part is something that there are a lot of methods for, but not also with nanobubbles at the concentration that we can. So we're forming these charged gas particles that are 1,000th of thickness of a strain of hair, and they do not rise because they're neutrally buoyant directly due to the size, because Brownian motion will overpower the ability to rise to surface. And these nanobubbles, when you get down to the size, you get into a realm where they possess a lot of other properties. And these properties are catalyzing these physical and biological and chemical reactions. So we're producing trillions of approximately 100 nanometer sized bubbles, and these are invisible to the naked eye. You can see the presence of more particles, more nanobubbles in a system. You can't see the individual bubble. But you can easily do this with a laser beam through a glass of water with and without nanobubbles. Here, deionized on the left-hand side, and nanobubble water on the right hand. The more visibility, the more nanobubbles to reflect. As you can see in the bottom picture here, in the middle glass, 300 million nanobubbles per milliliter. And then the last one, 600 million nanobubbles per milliliter. A milliliter of water is less than a teaspoon of water. So it's actually very mind-boggling to understand the amount of nanoparticles that are actually present in these glasses of water. But if you want to have a more scientific approach to measure size and concentration, you should use something called NanoSight from Malvern. We use this to quantify the size and concentration, like you can see here, the laser is then reflected back, and the computer is characterizing the bubbles, size, and concentration, allowing us to see this in a graph. For example, like UCLA did here for us in 2017, quantifying the size, which I said was the most, the majority of nanobubbles that we produce are in the 100 nanometer size. And at the time, they were also able to monitor how long they stayed in solution and prove that they are stable for months at a time. So nanobubbles in themselves is not really it's a known phenomenon. It's been a known phenomenon for over 30 years, but it is in the last years where we've been able to accumulate more knowledge in regards to the fundamentals and the application areas of nanobubbles. So when it comes to fundamentals in themselves, there are over 200 studies available. Growth and welfare, over 10. Water treatment in itself, 15. Pathogen control has been very interesting, over 20 studies. And when it comes to the cleaning and biofilm removal, this scouring effect that I'll be talking about, there's a lot of available literature to that. And food processing, and of course, again, UCLA in regards to the oxygen transfer efficiency and the dissolved oxygen stability, over 10 studies. Now, when it comes to the modes of action that nanobubbles have, I want to address this and what it does in a recirculating aquaculture system. Now, our technology has a very high oxygen transfer efficiency in itself. So the dissolved oxygen part, fantastic. But we're also creating the nanobubbles that are stable, and they are creating a buffering effect. They're changing the quality of water so that it has a better gas holding capacity. You can describe this as a buffering effect. Our equipment is flexible in order to install easily. It's basically a section of pipe that you can put into an existing pump line. You can put it in line as a side stream, standalone. You can install it vertically, horizontally, doesn't matter. And it has a very small footprint. And very importantly, our equipment has a very easy ramp up and ramp down capability, meaning that if you turn off, for example, a cone versus our nanobubble generator, the nanobubble generator will start up again and have the same efficiency immediately. And you have a very, very good ability to tune it according to need. And it's reliable and has low maintenance. Now, looking at such an installation and how the process works, firstly and foremostly, to the oxygen transfer to the fish, that is taken care of. That's step one. And then you have the nanobubbles effect in the system. Nanobubbles have an internal pressure of over 400 psi. And essentially inflating it like a balloon, creating a hard surface around the nanobubble. And this has a hard shell, and under velocity inside pipes, this has a scouring effect, a cleaning effect. And this is ripping loose biofilm to the solution, suspended to the solution, so that it can go to treatment. And then you have another property of nanobubbles. They have a strong negative surface charge, which is attracting contaminants and these particles, coagulating them so that they go to flotation, making it possible for the mechanical filtration to perform better. So the cleaning and the coagulation is working hand in hand, cleaning the system. And this is giving an opportunity or a potential for example, if the system here was based on ozone advanced oxidation process, it's giving you the opportunity to reduce the amount of ozone needed in that system. And then you have the biological enhancement ability in the biofilter. you are able to take out more nutrients because of the O2 uptake rate, O2 transfer efficiency. And what I'm going to dive a little bit more into is the fantastic ability to improve the biomass kinetics, giving you better ammonia oxidation and VOD oxidation. So if we go even further down into the details here of the properties and going up to the high level. Nanobubbles have a surface area that is 2,000 times larger than a microbubble, meaning that it gets a very much larger area to treat. Nanobubbles, they reduce surface tension. They have this scouring effect that I mentioned, and the bubble stability in itself staying long over time. And a negative surface charge, giving the nanobubbles an electrochemical property. They have a hydrophobic surface and interact very well with hydrophobic surfaces. For example, nanobubbles that have a negative surface charge, they will then stick to other hydrophobic surfaces when they're clean, for example, inside of pipes, and coat them with nanobubbles so that it doesn't become so easy for biofilm to reform. And of course, the net mass transfer efficiency that we have and the effect that nanobubbles have on dissolved oxygen stabilization, this buffering effect. Going to the top, the effects and benefits on efficient oxygenation in itself. Yes, we improve oxygen use efficiency, and this gives a snowball effect really in regards to the operational cost. You are using less oxygen because you're more efficient, and you are then able to reduce the amount of oxygen that's produced, leading to less energy produced. And with the efficiency, you're able to keep the system more stable to improve feed conversion rates and support the fish welfare. On the nutrient removal side, we're increasing bacteria kinetics. I'm going to get more into that. That's the most important part, the most interesting part here. That improves the nutrient removal and biofilter performance and giving you better improvement of water quality, and I would add capacity. In the solids and protein removal, you're taking out these particles, cleaner water, lower turbidity, giving you, because of the coagulation effect, enhanced particulate and proteins removal, and you're enhancing the ozone and UV efficacy, reducing pathogens, removing biofilms, and you're able to mitigate H2S and other unwanted substances. So high level, we are essentially intensifying the process, improving the water quality and giving better fish welfare, reducing those costs and getting better results and giving the system more capacity as a result of this. So now I've gone through the properties, effects, benefits, but let's see this in a real live situation, shall we? So we've done a case study with Lodingen Fisk. They have a facility in northern Norway, and a part of that facility, the start feeding part, is recirculating based. And just to go through, this is for Atlantic salmon. The system has a maximum biomass capacity of 35 tons, this department, leading to the fish tank section of 14 circular tanks. This is freshwater. This is early in the production, and we're talking about 1,100 cubic meters. So to explain how we started this, this study was made in two parts. The first part was the week before they started up the nanobubble generator, giving us the opportunity to take samples before we started up the generator and that week. And then we came back again after 50 days after the nanobubble generators were started up and to see the long-term effects. So if you're looking at the schematic here, we established some sampling points right after the fish tank, after the drum filter, after the biofilter, And then after the ozone injection and reoxygenation using our nanobubble generator, and then having a sampling point right after the header tank, and then after the UV lamp. First thing that we looked at was our efficiency. The oxygen transfer efficiency that we established at this site was 94%. And we were able to show an oxygen reduction potential increased by 6.2%. What we firstly looked at, when we're talking about the scouring ability of nanobubbles, being able to quantify that first, we looked at the total suspended solids. So we took samples. If you look at the table on the left here, baseline before the nanobubble generator was started, and then after 24 hours, and then after 48 hours, showing that the total suspended solids increased, showing there's more particles present in those 2 days. Then we came back again 50 days later, and then we took a new sampling in regards to turbidity. What we saw is that if you see at 0.4 in the turbidity table, the one all the way to the right, this 0.4 is right after the header tank, after the ozonation, meaning that is where you have the best turbidity throughout the process, also before nanobubbles. But what we were able to do is stabilize the turbidity throughout the process. So all the darkest columns here is after 50 days of using nanobubbles, showing that the system is kept cleaner, and at the same time, we were able to give the facility the possibility to reduce the need of ozonation, reduce the need in itself. So, and this by 67%, and the water turbidity was reduced by 30%. So that's talking to the cleaning ability of nanobubbles, how it can help a system and reduce the need for ozonation. On the other part, when it comes to the biofilter efficiency in itself, we were able to monitor the ammonia, the nitrate levels, and we're able to document that the nitrite accumulation effluent of the biofilter was reduced by 70%. And this was attributed to an ammonia nitrification rates were increased by over 60%. And this is what we need to understand a little bit more about. It's been discussed that since we're cleaning the system, that the system becomes clean, and then the oxygen and intensification of oxygen availability is doing this. But yes, yeah, in part, but not all. And this is something that we found more out of, and that is the role of nanobubbles in the nitrification and denitrification process. Is that they've shown an effect on the nitrification kinetics because of the oxygen and nutrient delivery to the bacteria due to capillary interactions with nanobubbles and the removal of inhibitory compounds such as surfactants and fatty acids. And these are short-term. And of course, effective COD fractionation and hydrolysis rate. This is both short-term and long-term. But most importantly, what we've seen through our research is the enhancement of the bacteria's production of enzymes and a catalytic effect for the enzymatic reactions. What does this mean? Well, it means that nanobubbles interact with microbes and bacteria to accelerate their metabolic activity. The increased metabolic activity results in increased utilization of organic matter in the water, leading to lower BOD and COT contaminants in the water. And a similar mechanism is happening with nitrogen compounds. The nanobubbles enhance the metabolism of nitrogen converting bacteria, leading to the removal of nitrogen from the water. So this part is something that we've seen much more research and this is in fact the real reasons for why we're so efficient. All in all, the value of nanobubbles in this process is the potential reduction of energy consumption for aeration. A system like this can use less aeration for especially the taking out of particles part, increased sludge-to waterability, and increased biogas production in concentration, and reduce the chemical consumption because the chemicals are working much better with nanobubbles, or enhancing the effect of them, and therefore increased treatment capacity. And all in all, there is a large reduction in cost of this treatment. So with this, I'd like to say thank you to Lodingen Fisk, specifically to CEO Truls Olsen and operations engineer Konrad Höning, who have been very involved in this process, to document how we are able to enhance these recirculating aquaculture processes. This two-part report was reviewed and approved by Lodingen Fisk, and it was documented by our very own Federico Piscini. So with this, I would like to say thank you for being able to share this with you. And if there's any questions, I'll take them now. And if we're not able to get to them all, please send me an email, and I'll get to it as soon as I can.
Thank you so much, Jan, can you hear me?
Yes.
Okay, perfect. Thank you so much again for the insightful presentation. It's really fascinating to see how nanobubble technology can make such a significant impact. So now is the time to open up the discussion part. I will start first with a question from Nuno Leite. Nuno asked, can nanobubbles be substitute for ozone, or they perform better as a complement?
They perform better as a complement. We do not replace that. Ozonation is an oxidative process. The only thing that we're doing is we can enhance it. We can improve the efficiency of it, making sure that it doesn't need to work as hard. That's more the message.
Mm-hmm. Thank you. The next question we have is from Garazi Rodriguez. Are they useful for stunning of fishes?
No, I would not say so. No.
Thank you. Let me just say that any questions that you might be having, now is the time to ask the question. So feel free to write it down in the Q&A box. The next one is from Alistair Lane, Executive Director of the European Aquaculture Society. Alistair said, thank you, Jan, for your informative presentation and your support of EAS. And there are potentially huge positive effects of nanobubbles. So what are the risks, gas bubble, disease, others? And what kind of new studies are required now to further validate the technology at industry level?
Well, I mean, that's a fantastic question. What we do see is that, I mean, when it comes to a lot of different species of fish, there are a lot of studies out there on the health of the increased fish welfare and health of fish, better feed conversion rates, and relative growth index. These are very, very interesting things that we would like to look at more and replicate also for salmon. So if there's anything that I'd like to do is more studies on that. We did, if any of you have read this report that has been made public, it's there are many articles on it, and one thing that was observed in this report is looking at feed conversion ratios and relative growth index. These are only observations because we need a more fixed control in order to verify and make sure it's documented well. But there were observations that were very encouraging in that direction, and that's what I'd like to look further into.
Thank you very much, Jan. The next question we got is from Jack Yavis. How do changes in water chemistry, for example, pH salinity, impact nanobubble characteristics and efficiency?
When it comes to the pH in itself, I can't really speak to that, but yes, when it comes to salinity, and yeah, of course, when it comes to the field conditions, water quality will have an impact on the concentration of nanobubbles. This is this can be different from water quality to water quality. Not sure if that answered the question, but please send me an email if I was not able to answer that question to your liking.
Thank you very much, Jan. The next one we have. Do you know if there is some differences between freshwater and seawater in terms of efficiency?
Yes. When it comes to the solubility of oxygen into water, it is better with fresh water than salt water in itself. But our process becomes more efficient with seawater than fresh water. We're very, if you're comparing to anything else, we are more efficient overall, but I'm talking about regular methods, traditional methods. But our process is very efficient in seawater. But if you're comparing, we're not inefficient in freshwater or clean water. So yeah.
Thank you. Are there issues if the nanobubbles get into the biofilter? Will they affect the nitrifying bacteria?
Like I just went through, I think it's very clear that that is a benefit, absolutely a benefit to have nanobubbles with our equipment and the way that we're able to adjust the system with the concentration of nanobubbles that we can provide. It will be absolutely a benefit to increase the biofilter efficiency. So there's no detrimental effect. There's no unwanted aspects of that.
Thank you. Laurent asked the next question. With this incline generator, you have the same results of like NEO 150?
NEO, I'm not sure. I'm not understanding the question.
NEO 150.
Oh, this is one of our products. Can you please ask me the question again?
Yes, with this inline generator, you have the same results of like NEO 150?
Well, the NEO 150 is our product. I would say that the one that I've shown here is just a different product, and in any case, we would have to understand the process and size the right nanobubble generator from Moleaer for a specific objective. So I can't really answer that question because you need to take that approach.
Thank you. The next one we have is from Michele Zoli. Sorry, I missed what you meant by increases biogas production. If you can explain that, please.
Yeah, well, in many processes, the nanobubbles are actually increasing like I said, the efficiency of the bacteria and enzymes, catalyzing that effect. So you're actually getting a better production of that in that part of the process. So in digesters. Yeah.
Thank you. Michele asked again, have you ever performed a life cycle assessment to evaluate the benefits also from the environmental impact point of view?
The environmental point of view, yeah. Well, I'm very glad that you asked that. In regards to nanobubbles, I mean, like I said in the beginning of the presentation, we're using nanobubbles to bring back the natural processes in lakes and ponds. So with nanobubbles being discharged back into nature, right? What we're seeing is that it has a positive effect on marine and aquatic life, both flora and fauna. So it's and when you're using air nanobubble and oxygen nanobubbles, it has a positive effect on the environment. It's bringing back what we want: better fish environment, better seabed environment. So I'd say that it's absolutely positive.
Thank you for this. The next one is from Konov Maxim. Kind of we can follow up on the answer that you just gave to Michele. How does nanobubble technology align with current regulatory standards and certification for sustainable aquaculture practices?
Well, in regards to, I'm not exactly sure how to answer that question. Well, the thing is that, can you take that question once more?
No problem. How does nanobubble technology align with current regulatory standards and certifications for sustainable aquaculture practices?
Well, I think that we are absolutely aligned because it's giving all the benefits in order to sustain better life, better production, and of course, most importantly to that is the fish welfare. So.
The next one from Maxim is what future, he actually asked three questions. So the second one is, what future developments or innovations can we expect in the field of nanobubble technology for aquaculture?
Well, I mean, the future developments in itself, I mean, when it comes to this, it's we're trying to improve all parts of the process. We're very flexible in that sense, both when it comes to retrofitting existing, trying to improve them, making systems that are very, very adaptable. So that's one part in order the adaptability of each of our or taking, like I said, tailoring the technology into so that it can be used in lots of different ways. And all in aquaculture, no facility is the same. So we have to have a very flexible approach to how to solve each application. And of course, there's new parts when it comes to how can we, for example, put in a nanobubble generator that is specific to improving heat exchangers, the ozone process in itself, because what we are good at is injecting all kinds of gases and all kinds of liquids. So yes, I can't go specifically into everything, but there are a lot of processes in a RAS system and other systems in aquaculture that we are looking at. Yes.
Thank you. And the third question is, what are the common challenges faced when implementing nanobubble technology in RAS, and how does Moleaer address them?
I love this question. When it comes to, I mean, the difficult part is because there's already established many facilities, and they are based on a pipe size and a flow of a specific flow through these pipes. And what this can make it difficult in order to do a retrofit when a customer wants to. And they say, well, we have cones from before, we have this another type of oxygenation. Um, why should I change? Well, the thing is that we say you don't have to change. You don't have to change the existing oxygenation system. If you have an oxygenation system that's working, fine. But you don't have nanobubbles. So what we can do is put the nanobubbles into just a section so that you get those benefits as well. And it doesn't mean that you're doubling the amount of oxygen that you're using. You will only need just a fraction to be able to do what we do with our technology, because our technology is able to produce an enormous concentration of nanobubbles without needing to oxygenate for the fish. So I would say that this is something that a lot of customers kind of like. Well, this is a huge cost to change out my entire oxygenation system, and a lot of people don't know. You don't have to do that. We can just add the nanobubbles.
Mhm. Thank you very much, Jan. The next one we have is from Patrick Sorgelus. What happens when the nanobubbles are ingested by fish?
Well, there are, if we kind of take a look at the particles in themselves. I mean, this is a very common question when it comes to the health of the fish, the gills, the mucus layers. All of this we've tested with industry leaders, fish farming leaders, and we see no detrimental effects to the fish when it comes to ingesting. What one should know is that the water in itself has an enormous amount of particles, nanoparticles from before, and we're only adding a few to that are very effective. So there's no detrimental effect to the fish.
Perfect. That's really important. The next question we have, is there any applied case for indoor shrimp farming?
Yes, there is. Please send me an email and I will send you a reference.
Jan, we have received many questions, which means that the topic that you're presenting today is really interesting.
Okay.
Would you be open to stay 5 more minutes longer? And then I
Sure.
will try to group the questions. Okay. Perfect. Thank you very much. So let me see. Okay, Jonas Juncker asked, thank you, Jan, for the presentation. Could you put some words to nanobubbles versus cones from a coast point, from the coast point of view?
Fantastic question. Completely honestly, cones can have a fantastic transfer efficiency in itself. I mean, we are speaking about the higher pressure, injecting oxygen into water with higher pressure, and you're able to have high oxygen percentages in that water. Cones in themselves don't produce nanobubbles, so there's one obvious thing. I'm not gonna stand here and say that we necessarily oxygenate much more efficiently when it comes to the injection than a cone, but the utilization of the oxygen with immediate injection and movement of that water can be more efficient than the usage of a cone, and the concentration that we are more aligned with the need. I'm not going to go into that deeply because there's a lot of different applications here, but where we can have a benefit is on the energy side, energy and the footprint of itself. Cones have a very large footprint, and if that system uses needs high pressure, then we can potentially lower that energy need.
Thank you very much. The next question we have is, Indras, what are the potential uses of nanobubbles in saltwater crustacean larval rearing? Also, are nanobubbles potential harmful to larvae?
I would say no, they're not harmful to larvae in regards to all the research that we've done in regards to biology. But when it comes to that specific application, I've not been honestly, I've not been that much. I haven't looked into that much, and I would need to have my team to take a look at it. So if you're interested in exploring that, so please send me an email.
Thank you very much. Can you measure the content in the nanobubbles like nitrogen N2? Nanobubbles in the fish water can uptake nitrogen.
Was that two questions?
Yes, it was a question and a statement.
Okay, so the first, so the first question is just isolate that. If you can measure the content in the nanobubble. If that's the question, then I mean, we're forming nanobubbles based on the injected gas. So the gas source and the purity of O2 or nitrogen is going to consist of that. So that's relatively one-to-one.
Thank you. The next one is from Jack Jarvis. Is more CO2 striping required when using nanobubbles compared to oxygenation/aeration systems?
Good question. Okay, so the answer can be both yes and no. If you have a system that is dependent on the oxygenation effect in itself, let's say you have diffuser hoses and this is a stripping effect, right? These bubbles are going to surface and then you have this aeration in itself. So this process is two-part. It's stripping and it's also oxygenation. So if a system is dependent on this and you're only using nanobubbles where we're very efficiently adding oxygen, but not, let's say, throwing away oxygen, if you will, then yes, you may need to add a stripping effect. But if you have that from before, no.
Thank you. Sriviam asks, how long does nanobubbles take to come to the surface of the pond when injected in the pond bottom?
That is very dependent on water quality in itself. Meaning the water quality is going to determine the longevity of the bubble and the content. So the content of the water has a lot to say, because there's not only sticking to the electrochemical, the electrical charge, making it attract to the surface is only one of many things that the nanobubble can be utilized for and be used up. Right, so dependent on water quality. Difficult to answer.
Thank you very much, Jan. So I will only ask one more question. We did receive many more questions that unfortunately we did not have time to answer on them today, but Jan left his email here, so feel free to write it down and ask him any questions that you might be having regarding this topic. So the one question that I will be asking now is from Dirk Schell. Did you recognize any effect on off flavor?
When it comes to jasmine, MIB off flavor compounds, there are studies when it comes to this in itself. Yes, there has been studies showing that nanobubbles can mitigate off flavor compounds, but to be honest, it is a little bit of a piece of soap, if you will, because replicating these projects, I was called not projects, but studies, if you will, there are a lot of components to it. So, but in essence, yes, we see, and what we do see is that instead of trying to get rid of already established jasmine or off flavor, we see it more as that it's more beneficial to use nanobubbles in your system constantly, thus mitigating. So that's my take on it. But there needs to be done more studies on it. But we do see positive effects.
Thank you very much, Jan. I would like to close this webinar today. I feel like we could discuss this for the next 1 hour for sure. So I would like to thank you all for joining us today and for your active participation. Thank you very much, Jan, for the informative and engaging presentation and discussion as well. It's really clear to us that the nanobubble technology has the potential to transform how we approach aquaculture sustainability. If you would like to rewatch this webinar the next week, I will send you the video recording of it. And you can also visit our EAS website to get the presentation slides of Jan's presentation. Don't forget to follow up on Moleaer's social media for the latest development in aquaculture and nanobubble technology. Thank you very much for joining us today. Have a wonderful rest of the day and hopefully see you next time. Thank you very much, Jan.
Thank you.